And here we are again. Oh my goodness. So...
And here we go.
Here we go. These notes are titled Dividing Polynomials. Polynomials. So the first thing I want you guys to do is recall regular long division, and then we'll build off of that. So recall long division. So for instance, say we had 873 divided by 14. We wanted to do this without a calculator. A little hint or trick to remember how to do this, you might have heard is in and out. In, out, where the top number goes inside the division box and the bottom number is on the outside. So here we would have in 873 in the box, on the outside 14, and you just divide. 14 can't go in the 8, 8 is too small, so then you move on to 87, and you'll have 6 times 14 is 84. Then you subtract these and get 3, and then bring down your 3. It's just remembering how to do this. Then 2 will work, and then 28, and then 5. Normally we could keep going and put a decimal up in there, but for now and for what we're going to be doing, we'll stop here. And remember that this was called the remainder, and we would write this as 62 and 5 over 14, or 62 and 5 fourths. 14ths. So this was the remainder. 14 is called the divisor, and 873, that's called the dividend. Dividend. Those are just the parts of a division problem. So we're going to take all of this stuff and we're going to use it to divide polynomials, things with x squared plus 3x plus 7 or whatever, and we'll be dividing those. So the first example, we're going to have this be example 1. And the instructions are divide. And we're going to divide x squared plus 3x cubed minus 4x. We're going to divide that by x minus 1. And I'm going to write down steps as I go. So the first step when you're dividing polynomials, instead of regular numbers, the first step is to arrange them both, the dividend and divisor, top and bottom. Arrange them by descending order. Descending order of their powers is what I mean, or their exponents. 2, and then here's a 3 here, and then a 1. We want it to go 3, 2, 1, or just descending order. So first one is arrange terms in descending order. Arrange terms in descending, I don't know how to spell this, descending order. So in this case, this is the highest power, so we'll have 3x cubed, this is the next highest, and it's positive, so plus x squared minus 4x. This is already in descending order, so I have x minus 1 on the bottom. And then remember in and out, so I'm going to put that as a note up here. Remember in and out. I'm going to put that in blue. So here, this goes on the inside, this goes on the outside. So we'll have 3x cubed plus x squared minus 4x on the inside. In and out. That's what a hamburger's all about. I don't know if that's the way you're supposed to sing it. I don't know. So, we're going to divide this. The first thing that you want to look at is this term and this front term. That's why we had to have it in descending order, so so that you can look at the first terms. So I'm looking at this first term and this first term, and I'm thinking to myself, what times x will give me 3x cubed? That's the question. That is the question. So what times x will give me 3x cubed? Well, I need a 3, so 3 times x will give me 3x. Well, then 3x squared will give me 3x cubed. And then I get 3x cubed down here. What I'm doing to get this is I'm going this times this whole thing. So on the side, I'm gonna show you right here. What I'm actually doing, can you guys see this? Is 3x squared times x minus 1. This is the work for what's happening here. And then this equals 3x to the third minus 3x squared. So that's what comes down here, minus 3x squared. And what I'm going to do is, just like up here, I went 87 minus 84 to get 3. I'm going to do this minus this. So what I usually do is I change this sign, and I change that sign. That's the same thing as subtracting, just doing the opposite sign. And I put them in blue just so you know that I did that. It's not how I multiplied it out. So then these cancel out. I have 0, x squared, so that's plus 4x squared, and then just like in the regular division, I bring down whatever I have left. And then I go again, except for this time, I'm looking at this term, but I'm still looking at that term. So what times x will give me 4x squared? And I can do the work over here. Well, I need a 4, so, and it's got to be positive because I'm trying to get this the same. I want to get something times this to give me exactly this. So 4 times x, I think will do it. And we can check over here, 4 times x. You won't be doing this work in your problems, you'll just do it in your head. Alright, I think you'll do it in your head, that's what I do. So 4 times x minus 1, so I'll get 4x squared, that's exactly what I wanted, minus 4x. So 4x squared minus 4x, and then I'm subtracting it, so I'm going to change each of the signs. That's what the blue is, me changing the signs because I'm subtracting. So then these go away, and then these go away as well. So I'm left with a remainder of 0. I have nothing more to bring down, so I'm done. The answer in this case will be just on the top, just like here, 62, and if we had a remainder we'd put that in there also, but we don't have a remainder here, so it's just 3x squared plus 4x. I'm going to do this in green. This is my answer, and it was up here. Now, the way I got this term, remember, was by deciding what I can multiply by x to give me this. So that's where this is. This came from there. Okay, that's pretty much it. So the steps, first we arranged in descending order. That was this part. The next step, which we didn't have to do on this problem, but we will later, is input 0 placeholders. Input 0 placeholders. It's not the amount of placeholders you're putting in. You're just putting them in. It'll make sense later. Third step is in and out. Put them in the boxes or the box and divide. So in, out, double. And then look at the first terms. So I'm looking at the first terms here, and I divide. So that's look at first terms, and then do the division. Divide and conquer. So that's an example where there's a 0 as a remainder, so you can just write down your answer. On the next example, there will be a remainder, and I'll show you what to do with that. So